Okay, so today we're working with triangles. So we have some definitions first, then we go on some angle theorems to end. Okay? So first thing we need to define is how to define what triangles are. So we have four different types of triangles. We have a scalene, isosceles, equilateral, and a right angle. So scalene triangle. Characteristics there, no equal sides and no equal angles. So the side lengths are all different. As you can see here, this has 1, 2, 3, which indicate they're all different. And plus, all the angles are different. If this was a close-up shot, this would have like 1 ring, 2 rings, 3 rings. So scalene, no equal sides, no equal angles. Okay. Now, you have an isosceles. And you can look here, it has 2 equal sides. And if it has 2 equal sides, it also has 2 equal angles. So 2 equal sides, 2 equal angles. And the angles always occur, how would I say this? Not where the 2 equal sides meet, but the kind of the bottoms of the 2 equal sides. Okay. Now, equilateral triangle has 3 equal sides. And because it has 3 equal sides, it's also going to have 3 equal angles. Therefore, the angles are going to be 60-degree angles. Right? As we'll learn in a couple minutes, triangles come out to 180 degrees. 180 divided by 3, 60. And the last one, a 90-degree triangle. This is the most obvious thing ever. Has a 90-degree in it. Now, there's no hard and fast rule about how many other equal sides, because you could have 2 equal sides there. Right? You could have this side and this side be equal, right? Or they could be different. So a right angle could be a scalene or isosceles. There's no way a right angle can be a equilateral because it has a 90-degree angle, and equilateral triangles all have 60-degree angles. So that's the first part. So first theorem here that we're working with, triangle angle theorem. Sum of angles in a triangle theorem. So SAT is all angles in all triangles add to, let me use my pen here because it's more, stands out more. They add to 180 degrees. Okay. So in this case, if I add it up, 70 plus 60 plus 50, it's going to equal 180. 60 plus 50 equals 110. 110 plus 70 equals 180. Right? So hypothetically, if I was missing this one, and we name that A or whatever along those lines, right? I would say, okay, I would go 180 minus 89 minus 54 equals, I think that number is 37, if I'm not mistaken. And then I would say SATT. So all angles inside a triangle add up to 180. So this is a really neat one that kind of sometimes takes a little bit of time to understand. It kind of takes a little more time to see, but once you see it, it makes your math much easier. Exterior angle theorem. Exterior angles are equal to the sum of the 2 interior angles. To opposite. I'm going to put opposite there. Okay, so not the supplementary angle, but the two other ones. So in this case, this angle plus this angle equal this angle. Okay, so 60 plus 40 equals 100. I'll show you the math of it, right? Because once you see the math, it kind of makes sense. So if we were to say, okay, this equals 180 altogether, right? So 180 minus 60 minus 40 equals 80 degrees. So that means that's 80 degrees. So always these two here, 180 minus these two here, are going to equal this one. But then if you think about it, this is a straight line. So 180 is a straight line minus 80 equals 100, which is also the sum of these two, right? Because if I go 100 minus 180 minus 100, I'll get 80, right? So that's why that kind of works. And once you see it, it'll save you a step, like a little bit, it'll take you a step in math. Because if I didn't have this number, so hypothetically, let's say this number didn't exist. What you would do right now is you would go, okay, these two added up, what you would do is 180 minus 60 minus 70 equals, what's that, 130, right? Which equals 50. So that means that's 50. Now that's a straight line, and you go 180 minus 50 equals 130, right? So that's a two-step solution to get to, right? If I wanted to do this in one step, I'd say, okay, this here equals these two added up. So I just go 70 plus 60 equals 130. And there, I have it right away. So that is, what's that? EAT, exterior angle theorem. Now, I'm going to change this here. This is a key point. The sum of the exterior angles of a triangle are 180. Okay, so just remember that, 180. Sorry, not 180. What am I thinking here? 360. Okay. Now, I'll put a note here, and we'll work on this next lesson. Exterior of any shape is 360. Okay, just keep that in the back of your head. So the exterior angle is always equal to 360. So if you look here, exterior, so I have equilateral triangle. So if I drew straight lines off all these, 60, 180 minus 60 equal 120. So if I did 120 plus 120 plus 120, it's going to equal 360. Okay. And if we shift it around here, 60, 80, 40, right? We're going to get 120, 100, and 140. If you add those up, 120 plus 100 plus 140 equals 360. So the outside of the exterior angles of any triangle are going to equal 360. Okay. Now, this one here, two angles in isosceles triangles are equal. So if you look here, isosceles triangle, therefore these two angles here are going to be equal. Isosceles here, the legs of these are going to be equal. Now if I gave you a triangle like this, let's make this a little smaller. I told you that was 30. I asked you to find me what this one was and this one was. You'd say, okay, well this one here is going to be 30 because of ITT, right? Isosceles triangle theorem. These two are going to be equal. And this one here is going to be 180 minus 30 minus 30, okay? Which will equal, what's that, 120, right? And lastly, we kind of did this one on all angles equal angle triangle are 60 degrees. So we're going to work with these with our worksheet now. Okay? Keep that sheet on you. It's a money sheet. So I might have to jump back and forth for my my solutions are y. So here, simple triangle. Well, what does a simple triangle add up to? Well, it adds up to 180 degrees. Let's go 180 minus 80 minus 30, which will equal 70. So that is 70. That's what? SATT? Just write that down there. Same thing down here. We have triangle, right? So let's go 180 minus 40 minus 90, which equals 50 degrees. So this is 50. How do I know? SATT. Okay. Oh, isosceles triangle now. So let's change the blue. Now we're trying to fill in all the space here, right? So first thing I know, isosceles triangle, I have two angles that are going to be equal. It's going to be this angle and this one. I know that through ITT. Then I have one angle left in my triangle. So I know that the whole triangle is 180. I'm going to minus 30 off it twice because that's the two angles that exist, which give me 120 degrees, which also gives me the worst drawn triangle in the world. And that would be SATT. This one here, we kind of go backwards. We have the tip, we're missing these two. Well, we know they're equal, so I could almost give them like the same letter, right? And I could say like, well, if I figure out how much is left in my triangle, so I have 180 degrees at the first, I'm going to minus off 40, which will give me 140 left. Now I have two angles out of the same, right? So I'm going to actually divide this by 2, since I have to share this degrees between two angles. So that means it's going to be equal 70. So these equal 70 each. Actually, this would be a SATT and a ITT reasoning. Let's slide over here. Well, this is a little odd. We have angles on the outside. So what do we remember about angles on the outside? Well, hopefully remember that the angles on the outside equal 360 degrees. Well, if all the angles on the outside equal 360, and I have two of them, I need to just find the remaining. So 140 minus 120. So that's 200, which take me to 160, and these add up to 60, so that's going to equal 100 degrees. And I can always check by adding them all up. And that was, what proof was that again? Exterior angle? What's that exterior angle thing called? Seat. Where's my pen? There we go. There we go. And I'm more concerned whether you know how to do it than the special letters, but knowing the letters kind of reinforces it. Okay, I got equilateral triangle. So since it's equilateral, I know that this is 60, this is 60, this is 60, right? And that is because of our exterior angle, equivalent triangles, equilateral triangle theorem. So ETT, ETT. Now, what do we have here? Okay, we got an outside angle and two inside ones. Well, we know that these two add up to this, right? So 80 plus 40 equals 120. So this is 120. And that is our exterior angle theory, EAT. Now we have kind of a same thing again, but we have an extra step here. So what I'm going to do is I'm going to find x first. So I'm going to color that red. We're going to go 60 plus 20 equals 80. So we know this is 80 degrees because of EAT. Then I'm going to use straight line is 180. So I'm going to go 180 minus 80 equals 100. So that is 100. And what's that supplementary angle? Oh, now we got a doozy here. Got lots here to figure out. So what can we figure out first? Let's figure that out. Well, we have a straight line here, so I can figure y out. So I can go 180 minus 50 equals 130. So that's 130. And that is because of SAT, right? Supplementary. Now, if you look, I have 2 of 3 exterior angles, right? 2 of 3 exterior angles. So those should all equal 360, although yeah. So the Z is going to equal 360 minus 130 minus 110, which will equal minus 200, which will be 160 minus 40, which will be 120. Yeah, 120, and that was our exterior angle theorem. And then I'm going to use straight line here to find x. So x is going to be equal 180 minus 120 equals 60, which then will equal, this will equal 60. And away we go. And there's our 3 answered. Oh, and this is SAT. So sometimes you just got to kind of plug away at it. So let's find x and y here. All right. So first thing I'm going to do is I'm going to find this. And I'm going to use a straight line. So that's 180 minus 140, which equals 40. So we know this is 40. Now we know isosceles triangles, so these are going to be equal, right? So a whole triangle is 180 minus 40. I actually made this the same as above. So it's going to equal 140 for both angles. So let's divide it by 2. So 70. So 70 is going to be this angle and that angle. And that's through ITT and SATT. And this is SAT, like I said before. I'm going through these way too fast, I realize. I apologize. But I don't want the videos to be that long. So here we go. This should have a y down here. That's what we're trying to find here. So first things first, let's try to find our x. Because we don't have any information on this triangle, so I can't find a thing about it. But our x here, we have an isosceles triangle here. So that means this angle and this angle are going to be equal. So this is 50 through isosceles triangle theorem. Now I have a straight line here. So I'm going to try to find this spot here. So straight line's 180 degrees. Minus off my 50, and I'm going to get 130. So in here is 130. Now, if I look here, I have another isosceles triangle, so that means this is going to be equal to this. So these are essentially 2 y's. So let's do this up here. So y is going to equal 180 minus 130, which equals 50. Right? And then I have 2 of them here, so I'm going to go 50 divided by 2 equals 25. Therefore, this is 25 degrees. So hopefully that helps you out. And I know my video is a little bit longer here, but we're filling in our notes of future self with which is important. Okay, so have a great day, and I'll talk to you later.